everyone, and welcome back for another deep dive. We get tons of papers sent our way, but this one really got us thinking.
It's a fascinating paper, really.
Yeah, it's all about LLMs, those large language models,
All right, right.
the ones that everyone's talking about. But this paper tackles this big question. Can we ever really stop LLMs from hallucinating?
Hallucination, yeah.
I mean, can we prevent them from just making stuff up,
Yeah.
giving us wrong information?
It's interesting because this paper, it doesn't just say, oh, let's train them better, let's just throw more data at it.
Yeah.
It actually goes deeper. It asks, are there fundamental limits here?
Right. It's not just about making them better. It's about, are there some things that they inherently can't do?
Yeah, are there things they just cannot do?
And I love how they set up this idea of a formal world.
Right.
Have you ever heard of this?
Yeah, yeah.
So, it's like they create this simplified universe in the paper where everything has a definite right and wrong answer. Like, we know for sure what the ground truth is.
Right, right. There's like this, what they call the ground truth function in this word.
Ground truth function,
yeah.
Exactly. And it's from that they then define what hallucination is.
Right, right. So it's any time that an LLM gives an answer that doesn't match this ground truth function,
Yeah.
they say that's a hallucination.
Yeah.
And they break it down even further. They talk about total hallucination where the LLM is always wrong.
Always wrong. Okay.
Some hallucination where it gets things right sometimes.
Okay.
And then the holy grail hallucination free.
Yeah.
Where it just never hallucinates.
The perfect LLM.
A perfect LLM.
Well, I hate to break it to you, but this paper says that might not be possible.
It might not be possible.
They actually make this bold claim. Hallucination, they say, is inevitable. Not just likely, but mathematically, it has to happen with any LLM, no matter how advanced we make it.
Yeah.
Whoa, hold on. How did they figure that out?
So they use this technique called the diagonalization argument.
Diagonalization.
It's a little bit mind-bending.
Yeah, diagonalization, it sounds complicated.
But it's basically, imagine you're trying to list out every possible answer an LLM could give.
Right.
Okay.
I'm trying.
Yep. What the argument shows is that no matter how you do that, there will always be some correct answers that are missing from that list.
Some correct answers are missing, so it's incomplete no matter what.
You just can't capture everything. It's
Yeah.
like trying to fit an ocean into a swimming pool.
Wow.
But-
So does that mean that we're doomed to these weird, hallucinations forever?
It's not about a specific LLM being flawed.
Okay.
Right. It's saying that there's this fundamental limitation.
Oh, I see.
Think about it this way.
Yeah.
Even the fastest car has a top speed.
Okay.
Right.
Yeah.
There's physical limits to what's possible.
Yeah.
And they're saying that there are similar computational limits to what LLMs can actually do.
So it's not about just training them better or adding more data. It's about there are just some things they fundamentally can't do.
Exactly.
That's crazy.
Yeah.
So this whole inevitability thing, it really comes down to what LLMs can actually compute. There are just some problems that are too much for them to handle perfectly.
Exactly. And they give this cool example in the paper to illustrate this. Imagine you ask an LLM to list all possible strings of a certain length using a fixed set of characters.
Okay, all possible strings of a certain length. Okay.
It sounds simple, but it's deceptively difficult because the number of possibilities, the number of strings explodes as that length increases. And they say that even the biggest LLMs we have today, they fail surprisingly quickly on this.
Oh, really? What's
They
that?
give this concrete example, listing all the strings of length 7 using only the letters A and B.
So just A and B, 7 letters long? That doesn't seem that hard.
It seems simple, but there are actually 128 possible combinations.
128. Wow.
Which is already a long list to write out. It's like 896 characters long.
Wow. It's more than I thought it would be?
Yeah.
Okay, so it explodes quickly.
It explodes quickly.
Yeah.
And the point they make is that even these huge LLMs, even with these enormous context windows, they can't handle this task.
It's like asking a calculator to do advanced calculus. It's just not built for that.
Yeah, exactly. You need a different tool for that.
So even these seemingly basic tasks, they can become computationally overwhelming really fast.
Yeah, they hit a wall. Not because they're dumb, but because the problem just requires so much computational power.
Oh, wow. Okay, so they hit a wall.
Yeah.
So what do we do? I mean, are we just stuck with these hallucinations? Like, is there any hope here?
Well, the paper does explore some strategies for mitigating these hallucinations.
Mhm.
It's all about understanding the trade-offs and using LLMs, strategically.
So there is hope. Well, that's what we're going to explore in part two. So, okay, we've kind of established this unfortunate truth that LLMs are going to hallucinate, at least sometimes.
It seems to be baked in.
It's baked in, but we're not totally powerless, right?
Right.
I mean, the paper you sent, it talked about some pretty clever ways to at least try to reduce these hallucinations.
Yeah, there are definitely things we can do.
I'm really curious to hear more about those. What are some of those strategies?
Well, one that might seem obvious at first is just, building bigger models, feeding them more data.
Yeah, like the merrier kind of approach.
Exactly, like if you want to see fainter stars, you build a bigger telescope.
Right.
So the thinking is, if we make these LLMs more powerful, maybe they'll be able to handle those really complex problems without hallucinating as much.
That makes sense. But I remember the paper saying there are some limits to that approach. Like, it's not a cure-all.
Yeah, you're absolutely right. It comes back to that core issue of what actually computationally possible.
Yeah.
Like if a problem just requires a level of computation that the LLM can't reach, then no amount of data or layers is going to magically solve that.
Okay, so it might help up to a point, but there's a ceiling.
Yeah, there's a ceiling, exactly.
Like, it's kind of like adding more lanes to a highway.
Oh, okay.
It'll help with traffic flow, but if everybody's still trying to squeeze through the same tiny toll booth at rush hour,
Right.
you're still going to have a bottleneck.
You're still going to have a bottleneck. That's a great analogy.
So it's not always about just brute force.
Exactly. It's about working smarter, not harder.
Okay, working smarter. So if just going bigger isn't always the answer, what about giving our LLMs like a little bit more guidance?
That's a really interesting idea, and that's where prompt engineering comes in, right?
Prompt engineering. Yeah.
Giving the LLM more context, clearer instructions, maybe even some examples of how to reason through the problem.
Yeah. This is something that I bet a lot of our listeners are already, playing around with.
Absolutely. And it can be incredibly powerful
Mm.
because by providing more context, you're essentially giving the LLM more clues
Yeah.
about the ground truth of the problem.
So you're helping it navigate that huge space of possible answers.
Exactly. You're narrowing down the possibilities.
Okay, that makes sense.
And there's, within prompt engineering, there's this idea of chain of thought prompting.
Chain of thought prompting, yeah. Yeah, I was really curious about that. Can you explain how that works?
Yeah, so it's basically like you walk the LLM through the reasoning steps,
Oh, okay.
almost like you're showing it how to think.
So you're giving it a little like a roadmap.
Exactly, like a roadmap. And it can be super effective.
Yeah.
But it's important to remember that it's not, a magic bullet. It works best when the problem itself is fairly straightforward and you can break it down into like clear steps.
Okay, so it has its limitations.
Yeah, it has its limitations. For really complex or nuanced tasks, it might not be enough.
Gotcha. So it's another tool in the toolkit, but we still need to choose the right tool for the job.
Exactly. And the paper also touched on a few other techniques just to give a sense of, how much research is happening in this area.
Oh, yeah.
For example, some people are experimenting with using ensembles of LLMs.
Ensembles, like a musical group.
Well, kind of. It's like you combine the output from several different LLMs, to get a more accurate result.
Oh, so it's like getting a second opinion from a doctor.
Exactly. More perspectives can lead to better decisions.
Makes sense.
And then there's this idea of building guardrails into the systems, like, rules that try to prevent the LLM from going off the rails, so to speak.
Okay, yeah, keep it on track.
Keep it on track. And then there's a lot of work on, incorporating external knowledge sources like databases or knowledge graphs. So you give the LLM a much wider pool of information to draw from.
Give it access to like a whole library instead of just one textbook.
Yeah, exactly. So, even though we have these limitations, there's clearly a lot of really exciting work being done to try to make these LLMs more reliable.
That's really encouraging to hear. But I gotta say, knowing that this hallucination thing is kind of a built-in feature, it makes me think, how should we as users, how should we be thinking about using these tools?
Right.
It feels like we almost need like a whole new kind of literacy,
Yeah.
a way to understand both the amazing power and the potential pitfalls.
I think you've hit the nail on the head.
Yeah.
It's all about becoming informed and discerning users.
Informed and discerning. Okay.
We need to be able to critically evaluate what the LLM is telling us,
Yeah.
understand when we can trust its output and when we need to be a little more cautious. And we also need to remember that these models are products of human design, you know,
Right.
which means they can reflect our own biases and limitations.
That's a really important point.
Yeah.
So where do we go from here? What are the big takeaways from all this?
Well, I think, first of all, it's crucial to remember that these LLMs, they're incredibly powerful tools.
Yeah.
They're already changing the way we work, learn, and
Yeah.
create.
Yeah.
But they're not magic,
Right.
and they're not a replacement for human intelligence. We need to approach them with, a healthy dose of skepticism and always keep in mind those inherent limitations.
So be enthusiastic, but be cautious.
Yeah,
They're amazing assistants, but maybe not quite the all-knowing oracles we sometimes imagine them to be.
well said.
Uh,
And that leads us perfectly into the final part of our deep dive.
oh, the final part.
We've talked about the problems and some potential solutions. But what does all this mean for the future of LLMs? What are the broader implications? Stay tuned, because we're about to explore those very questions.
Okay, deep divers, we're back. And, we've been on this journey, this deep dive into LLMs. We've seen the good, the bad, the potential. But now it's time to really think big picture. Where do we go from here? What does all of this mean for the future?
It's a big question.
Yeah.
I think this paper really drives home the point that LLMs, for all their power, are still machines. They,
Yeah.
they operate within the limits of what we can compute, and those limits, well, they're very real.
Yeah. It's like realizing, even the most advanced spaceship, it can't travel faster than the speed of light. There are just like fundamental laws of the universe we have to deal with.
Exactly, exactly. There are these boundaries we can't cross. And it makes you realize that, we can get so caught up in the hype thinking LMs are like on the verge of being all-knowing. But this research, it kind of reminds us they're not. We've got a long way to go.
A long way to go. And it really highlights the importance of, of us, of human intelligence.
Yeah.
Like LLMs can help us, they can augment our abilities, but they can't really replicate the full spectrum of human thought.
Yeah. Especially when it comes to things like common sense reasoning, ethical judgment, emotional intelligence. These are areas where humans still have a clear advantage.
So knowing all of this, how should we be thinking about LLMs going forward? How should we be using them? It feels like we need like a whole new way of thinking about this.
All new literacy.
Yeah, a literacy that allows us to understand the power, but also the pitfalls.
I think you're spot on. We need to become really informed users. Like, we have to be able to look at what the LLM is telling us with a critical eye to know, okay, when can I trust this output? And when do I need to be a little bit more cautious?
Yeah, be a little more skeptical.
A little more skeptical. And remember that, these models, they're designed by humans, trained on data, created by humans. So they can reflect our own biases, our own limitations.
So it's a bit like working with a brilliant but maybe sometimes unreliable colleague. You gotta appreciate their strengths,
Right.
but also be aware of their weaknesses and maybe double check their work when it really, really matters.
Exactly. And this paper, it really underscores the need for safeguards, what they call guardrails and fences.
Guardrails and fences, okay?
Yeah. We need to be thinking really carefully about how we design and deploy these systems so they don't cause harm. And so we're using them responsibly for tasks where accuracy is super important.
That makes a lot of sense. It's exciting to think about all the possibilities, but we also need to, proceed with caution. LLMs can be powerful allies, but we have to make sure that, that we're the ones steering the ship.
Yeah, we're the captains. And, it's not all about, preventing negative outcomes. There's a lot of potential for LLMs to actually enhance human creativity.
Oh, that's interesting.
The paper even mentions that sometimes, those hallucinations, those unexpected outputs, can actually lead to really fascinating and inspiring results, especially in fields like art and design.
It's like not all errors are bad errors.
Exactly.
Sometimes those unexpected detours, those lead to the most amazing discoveries.
Exactly. And LLMs, they could be incredible partners in the creative process, helping us to push the boundaries of what's possible.
I love that. Partners in the creative process. So, as we wrap up this deep dive, what would you say are some of the big takeaways here?
It's been a fascinating exploration, that's for sure. We've talked about these limits of computation, the importance of human oversight, the potential for challenges and opportunities as these LLMs become more integrated into our
Yeah,
lives.
yeah, they're already everywhere.
They are, and it feels like we're just, scratching the surface. There's so much more to learn and to explore.
So much more to learn, and it's changing so fast.
Exactly.
Yeah.
And that's what makes it so exciting. We're learning more about the nature of intelligence, both human and artificial, with every new discovery.
Well, that's a perfect place to leave it. But, dear listener, before you go, we want to leave you with a question. Knowing what you now know about LLMs, their limitations, how does it change the way you think about using these tools? What are your limits for trusting their output? We'd love to hear your thoughts, so share them with us. Until next time, happy deep diving.
Hello everyone, welcome to my channel again. Today I'm going to share with you one of the projects I have worked and got some satisfactory results. So basically this project can be implemented for many user cases. For example, if you want to get multiple PDF from the website and summarize the data and get some insights from it. So basically, this data I'm going to access is the Bank of Italy anti-money laundering sanction data I got from the Bank of Italy website, and I'm going to use the this code, the code I write with GPT to actually, first of all, to save the PDF information to a CSV file. Of course, you can choose to save to CSV or JSON. It's up to you. And I'm going to process this data, get some numerical insights from the data. Because usually, if you want to clean up the data, it will take many mundane process. So I wanted to do the text searching, but eventually I think maybe the local LLM is faster and more straightforward. Then you can see here in the first version, I did first of all the analysis without date because I forgot one of the important components of the data is to understand which date one entity is sanctioned. So later I did another um, round of the coding and with date. Okay, so just to let you know, because the first attempt to try these codes, I always miss something. So I will add that missing piece to the next part. The final part is called option of text searching. I'm saving this as a placeholder, so in the future I can compare the text searching with the LLM model to compare which one is better. However, at this moment, I think because my coding background is not so solid, so if I'm going to implement a very robust text searching algorithm to find patterns, it will take a lot of time. So today I'm going to go over the project with you. Okay, let's check the code. First of all, I'm going to get the data from this website. Basically, if you go to this web page, you are going to see there are some introduction and also a list of the PDF, all the links you can download. Okay, so basically in this part of the code, I'm going to use some, I think this is a traditional way to scrap the information from the website. And these I have done 2 or 3 iterations with GPT and also modify some of the components to make sure it works. And of course, I have also some of the manual adjustments. For example, like here, the pages of the website. I assume it has 19 pages. Okay, but this one, usually I would recommend to check the HTML file, check the website to understand which is the range, because make it too small or too large does not make sense and also can intrigue some of the errors of the code. In the end, this code will actually make sure all the information is properly stored in the CSV file. I'm going to show you quickly the CSV file is like this. Okay, usually it has the URL, it has also the text information from the PDF, and this will be the base for us to process. So then let's come here Okay, so here actually I'm implementing the local LLM. I did uh, download some of the LLM models to my LLM studio in local environment, so I can use this code to access that model. And more precisely, this will do the feeding of the information to the model and get a response. So I think the most important part is about, first of all, set the local server address and then extract the sanction information based on this part, this function. So basically, this function is going to intrigue this chat mode with with the model. Okay, so I have my prompt information here to get concise, structured information, and okay, I also said the maximum token is 200 because I don't want it to be too long. Sometimes if you don't set a limit, the model will go on forever and cost a lot of compute, and you are going to wait a lot of time. So and then here, this is a part of the function that actually gets precisely this information. Okay, so after running it, we can see here. Here is a data frame which we have. Yeah, we have partially the information. So what's the problem of it? If you expand the text content, yes, you can get the text content. You can understand it's a very long document. The sanction information, well, it can get some of the information, but it is not well structured. So you cannot easily process in the next step. So in order to separate the sanction info, I need to do more work. So in the next part, I uh, I repeat. Okay, I repeat all the algorithm. Actually, I um, make sure of course, I work with GPT to refine this part of the code to actually make sure it will separate the information to the data frame with separate column. Yeah, you can see here. Yes, we have separated them to sanction entity, amount, and also the reason. Of course, you can see here there are not many, not 100% um, accurate because you can see here some empty space and some zero amount. So there are some potential problems about the quality of the extraction or the data cleaning. Okay, but at least at this step, we can get the different column and we can further refine based on it. If you want to check any detail of the code, please pause. Then I actually uh, did the refine and also add the date in the next step. So here, I actually copy the output of the code to GPT to actually let it understand what are the tasks I need to do, especially about the data cleaning. For example, the amount number, most of them are not regular. For example, the punctuation, like the separator of the thousand number, 30, in Europe and in USA and in China are totally different. So I iterate several steps to get this part of the function to let the code to clean the data. And I refined my prompt. You can see now my prompt is very well structured, much better than the previous one. Previous one is just one sentence to ask it to get concise information and so on. But now I have different bullet points to let the LLM to get me these information. And about the maximum token, because as a rule of thumb, I tested and tried and saw the maximum token should not surpass 100. So this will speed up my processing time. Okay, so in the process text data part, of course, I iterate several times with GPT to actually make it more robust, because um, during the testing, this kind of code actually take a lot of time to get the right information you want. So after doing all these improvements, we can see the result. You can see it's much better because at least you see, okay, at the first, let me show you. At first, this is showing that the information is passed, which information is passed to the local LLM, and there are some ID, blah blah blah, different information about this instance, and then this is the extracted information, and I think it's a pretty good. Okay, this you can in this way you can check the process. Of course, in your LM Studio, you can always check the real-time processing of this data. So I'm just going to save your time because how to set up the LM Studio is quite easy. You just open it, choose a model, open the server, then you can use your code here to link to the local LM Studio. So these information are passed to the system and get feedback. But you can see here, like this one, the model is hallucinating. Okay, so after passing the text data to get the feedback, okay, and also more structured data feedback, in the end, we have, sorry, we have a very structured data frame. And you can see just from the displayed part, you can see the accuracy improves a lot. And I make a note. It took about 24 seconds for processing 10 records because at first I actually limit the page searching to one page of the Bank of Italy website. So more or less it got 10 records. And I used this stable code instructor 3B model, and it took 24 seconds. My suggestion is to always choose a lightweight model to quickly test your code and try other models, because I believe most of the listeners do not have a very big machine, so our resource is limited. So let's see how I get the dynamic scatter plot. For this code, I mean GPT can generate like a super fast and very accurate. I think from here I can see a different entity. You can also see the size of the circle to show the amount is quite okay. I think it's very useful for the data visualization. But you can see here some entities have very lousy code. Is not accurate. And you can also see some of the sentence. Let me try to check some to you. For example, like this one, because of some of the sanction is to person. So if I want to see um, like the aggregation or to an entity, this data has some noises. Like I do not want to see how much one single person is fined, is penalized. So this just to show you there are some limitations at this point. Then I choose different visualization. You can see that the package I used is Plotly. It's very useful, and you can see all the data, and of course you can zoom in and zoom out. So I also did the yearly trend data. Yeah, it's okay. So basically, I think by here I already finished the first version. The reason I do not focus on the different visualization part is because the package is standard. You can try anytime you want. Yeah, but from here you can see some of the entity name is very strange. Like this one, I believe it is not complete, or it may even be error. So how do I get to the next step? The next step, I wanted to try a different model. So, and also I try to save the data to JSON file. I did save to JSON file, but I do not find any particular advantage. So eventually I switch back to save to CSV. Okay, the CSV is like before. And in this version, this part is the same. Yeah, until here, yeah. So the same as before. The improvement is in this part. Uh, First of all, I get more structured prompts. And you see here, let's see this one. I believe I have done some improvements. Like here, my prompt is about this big. And here more robust, I think. Because now I want to assign a category. Because I want to see, because I know the reason can be 20 words, very complex, or very scattered. Now I want to summarize them in a more compact way, especially in the data visualization. So I tried this and also the category of reason, one keyword to put it in the model. And also I changed this model to Mistral 7B. It is a test for this model. And the rest of the code almost the same, but I add some more columns. I had to process. Like I said, every time when I first try the model, I try only 10 records or one page of the website. Okay, so I get a lot of response and also the results from the local model. Eventually, you can see the quality in general is similar, but later in the visualization, you are going to see there's no error code about error information about entity name. That is improvement. And you can see now the sanction reason. Let's try to check also the sanction reason. The sanction reason in the previous one, you see is not very organized. But here, you can see it is more structured, the response, like the violation to what and the failure to what. Okay, and category of the reason. Yeah, it's not perfect, but it can already summarize to a more compact way for me to understand which is a category. So reason is a long paragraph, but category is much shorter. I would expect to summarize only to one word, but believe me, I tried, but the result is not so good. Because sometimes even one word, it can use a separate dot or slash. So eventually it's not just one word. So if we want to refine the categorization, it needs more time and more design of the code. So yeah, now I have the new categorical stack. Let's see what it shows. Yeah, I think it's much better. Okay, so I have these different categories. It's not perfect. We can still work on it. But at this part, I think we can have a more compact one because, for example, like here, in here, this is April 2022. The most find reason is for transparency and cleanliness. I think you can get the insight from this data visualization. And I also tried to group by the first word of the category because I think this is too many words. I want to see more compact version. Yes, just by reorganize the data frame, show it in the graph. You can get it. For example, like let's say anti-money laundering and transparency. I think sometimes if you only see just one keyword, this categorization could mean something for your operational needs and for your understanding. Okay, dynamic scatter plot is like before, but I changed the layout of the graph. But you can see here, let me quick run through. You see these names are all company names. At least from what we see, there is no very obvious error code or individual name. So this is a huge improvement. But as I said, if we needed to actually detail in very detail to compare both process, different ways, different models, different results, we need a very detailed descriptive data. But at this point, I think this project already gets some very useful insights. So if I would like to choose to improve, I will improve on this version and use the Mistral 7B model. And you can see here, the monthly trend is like before. Yeah. And also the yearly trend. Yeah. One thing I want to share with you is that during the trial of this code of the graph, sometimes the system does not organize the data in a sequential way. You need to pay attention to it. If that happens, just check the code and make sure that you see sort some functions to sort, to group based on your need or user case. Okay, I wish this video is useful. Uh, Today I do not run it with the local LLM studio, but if you want to see the real-time processing, I'm going to make another video to explain. I wish this is useful for you, at least to let you know with ChatGPT and also VS Code and also LM Studio in local environments, you can already build some very useful project based on the publicly available data for you to get data insight and better visualize the data. Of course, based on this, you can implement many algorithms to do the prediction, to the regression, and so on. Wish you had a fun time and see you next time. Bye bye. Everyone, welcome to my channel again. Today I'm going to present you the project that I have successfully run in my local environment to build the AI agents and let them talk with each other. Um, First of all, the tools I'm going to use, first of all, is MLLM Studio. Uh, so with LLM Studio, you can download the model that you want to test and also to load it and to start the server. So to let the VS Code module to actually access to the local server and interact with the large language model that you prefer. Then, of course, we need the Visual Studio software installed so that you can run the Python code very easily. And the last and most important thing is that the AutoGen. AutoGen is a package, and also the I think a package is the right name because I'm going to import in the Python environment. Uh, this AutoGen is I think developed by Microsoft and is very useful for me to actually build this conversation program between different agents. So you need to pay attention to two parts. The first part is LM Studio page. It will tell you how AutoGen can interact with LM Studio. It is very in detail. You can test all the code, of course. The second part is about the group chat. Group chat is actually more advanced. So if you check this page of the LM Studio, it gives the example of two agents chats. So it's just two agents talking back and forth. But if you are talking about the group chat, actually the group chat will invite multiple agents to interact with each other. Okay, so I invite you to check these documents. It will be very useful for you to test the code. So let's come to the code part. From the basic, I just mimic what the document says. So first of all, I set up two models. Okay, so if you set, for example, this Llama refers to this Llama model, and also the URL key is the local LM Studio. You can find it, and also the API key is LM Studio. Okay, so basically setting up the different model will be useful when the agents will link to these models. And you can see here the second part is to from the AutoGen import conversible agents. This part is actually defining the different agents and which model it will use. So for me, I always use only one model. But if you want one agent to use one model, the other use another one, it is I think is possible, but you need more configurations of LLM Studio and so on. Okay, so basically at this moment, in my LM Studio, I chose the Mistral model, but here I leave it like this. It can run because I think LM Studio will recognize this kind of link um, directly without actually checking which model you are referring to, because actually the server is working with one model. So when you link to the server, it will work. Okay, so um, this is the code that you need to run the conversation. It will produce a chat results. Okay, so who will start the conversation? Jack will start the conversation, and it will talk with Emma. And the starting message is Emma, tell me a joke. Max terms will define maximum of the conversation passage is like if the maximum is 2, actually you have a you see here you have a 1, 2, 3, 4. I think terms, one term, two terms. One term is one back and forth. Two terms is in total two back and forth. Yeah. So you can see here the result is very good. Emma tell me a joke, and Emma starts to tell a joke. Okay, then Jack says, that was a great joke. I'm glad it brought a smile to your face as well. Then Emma, I absolutely agree. So they're actually doing this conversation, right? You can check and test by yourself. I think the more you test, you can find the different results. Okay, so at this point, we have mimicked the official example and tested it with LM Studio. This is okay. So I want to go to another example, which I tested to actually, I think if we want to apply this package of AutoGen to other use case, we need to have it in mind. For example, for me, I would really like different agents to build a financial analysis team to actually tell me if the stock is underpriced or overpriced, and if I should buy it or not. I think there are many examples on YouTube. You can also check. But here, okay, I just test what's my initial construction of this team, and to let them talk as a group. So this code, at the first part, I also define the different model, but now I'm more specific. I want to define the Mistral model that I'm using. So just to make sure that I understand the whole picture. The other two, I leave it here, but it does not make any impact. If you want, you can delete it. Okay, so about the agents. First of all, I created more agents. I create a team head of the team. The team head will do a lot of job. I just describe them all here. I think my code is correct, but if I'm wrong, feel free to mention it. Um, and here I actually describe the job it will do. It will be the leader of the team of stock analysts. You instruct the general analytical framework and ask analysts to process data and give investment strategy and suggestions. In the end, you combine opinions from both data analyst and the news analyst. Okay, in this part, I think the better you define the agent's role, the better it will run and get results in the later stage. So I also have the analyst on data, analyst on news. So basically, one will check the data of the stock, okay, financial data. I did not specify, but if it is recommended that you specify in a more detailed way. I also ask it to actually analyze trend, plot a line graph, and so on. Then about the analyst on news, I asked it to check the news and also give some summary and also provided the recommendation. So in the end, I want the team head to summarize. So go to the next part. The chat will initiate from the team head to the analyst on data, team head to analyst on news. Okay, so let's check the results. Maximum turn is 2, so I expect that it will be 2 back and forth. So, yeah, the message is analyze Apple stock. Okay, so basically the team head actually first talk to the analyst on data, give some feedback. I think this was the results we get from the model itself because it was trained on massive data sets. So actually, the model actually figure out this by itself. It I think it have to be not 100% accurate. So, but you can see here it structured this um, information I think very well. You can see historical stock price, earning per share, and eventually it gave the conclusion that a solid long-term investment opportunity. Okay, it looks very good, and you can also try in your local environment to check the whole response. Okay, also the if you check the LLM Studio because you are running a server, you can see the conversation and all the log. It is very satisfactory because previously I tried, if I remember correctly, is the UI version of the AutoGen. Actually, the configuration of the different agents and so on. Of course, you can do it in the browser, in the web browser, but it's I always meet some problem. For example, if the prompt is just one word, and the feedback is just 2 words, it's not working. But in VS Code with Python, Jupyter Notebook, it works well. Okay, so let's see. First of all, here, the first response from analyst to team head. Okay, then team head says, actually the team head is working like furthermore. He actually tells the analyst on data to pay more attention on the market developments and so on. So it's not like okay, I get your advice and I summarize your advice and that's it. Okay, it actually want to dig more to explore more with analyst. So yes, analysts also give additional comments about add additional information about the stock price, investment potential. So actually, it stops here. Okay, so when I reach this point, I realize that actually there is not another feedback. So uh, the conversation is complete. But if I want to get the conclusion from the team head, it does not give. So I need to configure either the conversation terms or I change the description of the team head and make sure it works better. Okay, so the is still prompt engineering as a basis. So the better you engineer the prompt, the better you get the results. So the system stop here and goes to the next conversation is the team head to the analyst on news. Okay, so at this point I realize it's a separate chat. Okay, so it asks the analyst on news to check. Okay, and it says I'm AI language model, don't have real-time access, of course. So it actually it gave some general analysis based on the information it has. For example, like this information is dated in 2022. So from the pure conversational point of view, I think it's working. Yeah. Then the team head tells to the analysis to news, in addition to the analysis above, it is crucial to consider both quantitative and qualitative factors. Uh, in my opinion, this is not very necessary because I would expect the team head to combine these two parts. Because the analyst on news is going to focus on the qualitative part, and the analyst on data is going to focus on the quantitative part. So that was my original design. Okay, so it asks this. I think in the future I need to better refine my prompt and the description of the role. Okay, so Amazon News says, okay, it actually does the work it asks to. Not only analyzing the news, but also to give some comments about the data and also examine the KPI and so on. And also it did the competitive landscape, management efficiency, and industrial trend comments. Okay, so actually, the analyst on the news is doing the job for the team head. You can see here the team head should do the final comment by combining both the analysis. You can develop a well strategy. Okay, uh, okay, but eventually you see this one the model becomes very prudent because it suggests that you should consult another financial advisor. So technically speaking, it is not doing its job. Okay, but you can see this flow of conversation is going, so you realize there should be some more adjustments, either with the prompt, with the max terms, job description here, system message, I call it as job description. Okay, so then I further refined the code. I tried the user proxy agent because I consider user proxy agent is that the user inputs will actually influence the conversation. So I set up this user proxy parameter according to the documentation of the AutoGen. So you can see here, there are some informations here like a name and so on. So then now I start a group chat. So the group chat is going to actually involve multiple agents here. For example, I have 3 agents: team head, analyst on data, analyst on news. And also I have max in around 6 because I think there are too many agents, so maybe I need a longer conversation to get a meaningful result. In the meantime, I'm trying to input my prompt. Okay, so it's not like previous version. Actually, I write a prompt in the code. Now I want the user input, so I input the prompt. Okay, the conversation starts. You see the user proxy is the user, me, will start the conversation. Uh, and conversation to the manager, and so the manager will go to the group chat in this sequence. Okay, let's see. Okay, the system take my input as the user proxy to chat manager conversation, and then analyst on data. Okay, says okay, I'm doing the blah 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 analysis. Okay, and yeah, it talks to the chat manager in summary. Okay, Amazon stock, blah blah blah. Okay, it does not give a very precise conclusion because it says you need to do further analysis. So it's not working very well. And then it says that it is important to keep in mind the past performance is not a passion. I think this is like a disclaimer from the banks, investment banks. Yeah, it's quite interesting. Uh, yeah. So then the group chat select the speaker field to resolve the next speaker's name. I think there are some issues with the naming of the agents. So if you see this kind of message, I suggest you to actually check. Uh, Actually, the next part, the conversation goes to analysis of the news. Analyst of the news. It says, yes, you're probably right. It's important to remember historical data. Okay, so it actually takes the as message of the disclaimer, so it does not do much job. Okay, and then it says absolutely providing clear. Okay, it's like not so useful, right? Is a writing disclaimer. So at this point, you can see the group chat actually goes, but I suppose there should be more definitions, like either in my prompt or in the structure of of the team and of the job description, right? To configure better these agents. Uh, but as a start, I think I would say this is okay. Okay, this model works, and I need to further refine to actually do the jobs that I intended to have them done for me. Uh, yeah. So this example stops here. Okay. So just a quick wrap up. You can do two agents back and forth conversation, or you can have a group conversation. Okay. So the next example, for the models, the definition are the same. I did not change. Uh, Actually, you can see, like the previous example, I ask the analyst on data to plot, to analyze a trend. Of course, it cannot. Okay, so I need to further work on it to see if I use some resource code to let the agent to act on to draw the graph based on the data, or I should just should test the different alternatives. But at this moment, I keep on going. So the job description actually, I did some improvements, some adjustments, and I'm inviting a coder and a tester. So, in my opinion, if you are going to invite a coder and tester to a conversation and you want them to write the code and test code, of course, there are many use cases that you can check on YouTube. But at this moment, if you only define it here, it will not work. I'm going to show you. So this part is the same. We are going to have a user proxy. Yeah. So just a reminder, whenever you see there are some comments here, you can stop the video and check. Some of the comments I leave the error message just for future check. For example, the original proxy code actually it asks for the Docker environment. I have never used it, so I want to skip it. Okay, so I need to set here user Docker force. If you want to refine this code, I think first of all, you need to understand the document of autogen of a specific function. And if you have some difficulty to modify the code, you can ask ChatGPT to help you. But remember, ChatGPT has limited capability. So the next part is still the group chat, but here now we have the coder and tester. Okay, next round 6. I manually insert my prompt. Okay, and here, I think you need to pay attention because the system will recognize the whole part. The message should have two components, okay? A complete one. Not only like this, the text information. You can try because you are going to see the error message. So I'm going to start the chat again. Okay, analyze Tesla stock. Okay, the log actually says group chat select speaker failed to resolve the next speaker name. Yeah. So there is some error, but here the team head starts to ask the analyst on data. Can you provide me the Tesla stock price and share the recent news about Tesla? Uh, and ask the analyst on news to share the news on Tesla. Both of them are working. Okay, so first of all, it promised that it will actually work and get the information. Yeah, also the news analyst on news, and the team has based on information. I would like to remember buying Tesla stock at current due to the strong financial from the earnings reports. Uh, I would say I don't see much data here for the team had to analyze. For here, the news, yeah, the news is positive. Okay, surpass the expectation earning. Okay, so it makes sense. But the capability of individual agents, like I said before, we need to enhance their capability. So this is a part of the conversation. Actually, the channel manager actually talks to a team head. Team head talks to analyst. Then we go to the next part, is the team head to the channel manager. Okay, give actually a response, right? It's very structured. I like it. Introduction. This is which company, fundamental analysis, valuation multiples. I think if you further modify the code, you can get a, the quasi professional report from this model. Okay, then you can see here they also did technical analysis and also news analysis. Uh, I mean, the accuracy, because it's not a link to the third-party API, not getting the news, I think is uh, not 100% reliable. But the next attempt in the future, I would try to like use a Y Finance or use the Google News Google News package or API to get such information to the model and let it analyze. Okay, so at this moment, we are always utilizing the knowledge base of the local large language model. Okay, so pay really attention to this. If you try to have fun and to test the model, yeah, it's okay, but to really use it, be very, very careful. Then here, uh, okay, you can see this is different from the previous one, previous examples, because we have more agents and actually we have modified some of the this job description of the of each agent. So you can the result has some improvements, I would say. And then we go to the next part. Actually, the team head. Now it's your turn to play a role. Which of the following roles would you like to assume? And what instruction or question would you have for the team members? Yeah, so it will select them and provide the instruction to ask question accordingly. Okay, so yeah, now analysis of data says diversification is an important thing and so on. This is quite general discussion now. And the coder says the manager, yes, diversification is okay, but the coder is not doing its job. So there must be some problem with my setting. Okay. In summary, it suggests a diversification. I mean, the primary job of the coder is to code. Okay. So actually, uh, okay, let's see here. The coder starts speaking again. Well said. Okay. I'm not sure which agent actually talks to this agent before because I don't see it here. Anyway, you can do different tests to check the workflow. There is also a very clear documentation of the AutoGen. I recommend you to read it, okay, because I'm also still learning. So in the next part, I actually make my prompt very, very complicated because I see the result is not so well. I said analyze the Tesla stock, starting from the team head to get a general plan of the task, then analyze on data to discuss with coder and tester to run a functional code to get analyze stock data. Let me see if I have a trunked version. Yeah, it's this one. It's easier to read. Analyze Tesla stock, starting from the team head to get a general plan of the task. The analyst on data discusses with coder and the tester to run a functional code to get analyze stock data and financial data and to give advice to the team head. Then blah blah blah. So now I give a very very clear instruction to the group. Let's see how it goes. So it takes the prompt, okay, and pass it to the chat manager. Okay, and the team head starts to talk back to the chat manager that I'm a team head. So yeah, how these agents will work. Okay, it's very well structured, right? So it first of all says that it will assign the task based on the expertise of the team member, three team member, very well organized. Okay, and it says using tool like Bloomberg, Y Finance, Fred. I mean, here I do not provide the Fred API or the Bloomberg API, so this is a very good assumption. but not very realistic for me to implement a free version on the local environment. Then once they complete their analysis, I'll combine the insight and give a report. Yeah, it's very good. So report, the outline of the report, it also describes, is very comprehensive. I like it. But you see here, group chat select speaker failed to resolve the next speaker's name. This is because the speaker selection call returned nothing. Okay. So I think this problem repeats. In the future, I need to check. Is that did I misspell the name of the agents, or there is other problem? So let's keep on going. The next part, actually, I think there is another solution to this kind of missing next speaker. It will pick another speaker based on the chat. There must be some logic behind. If you want, you can further check. So basically, now analysis on data, I think is based on the plan. It starts to check to talk with the manager. Okay, the team leader, I fully understand analytic tone and follow the objective. So there is a kind of mix up because analyst on data is not a team leader. Okay, he understands the job and starts to work as a team leader. So, but some of the part like this part, yeah, you are actually repeating the previous conversation. Not very useful. Okay, so now the team head to the manager, the team leader, my previous goal is blah blah blah. Define blah blah blah. Ongoing monitoring. Okay, sorry. Yeah, here. It describes its goal and so on. But not very concise, not very useful to actually deeper with the conversation. Then failed to resolve next speaker again. So still, this analyst on data chats with the chat manager. Okay, so it did what was already there, and he is taking responsibility of the team leader. Okay, but from the information of the step, you can see there are also some errors because here you see from point 1 to 5, then from 1 to again. So I think there is some problem with interaction with local LLM because the description of the task is too complicated, so the system cannot handle it. I see this kind of error sometimes before, just during the conversation with Mistral model. It will start to hallucinate with different code. Does not make any sense. Okay, so you see here, it tries to make up a lot of numbers, but they do not have any meaning. So at that point, the local server continues to run. I manually stopped it. Okay, so you see the error message here. This is part of the server log. You can see I take a screenshot. The server log actually shows infinite numbers. Okay, so that basically says this project has to be stopped. We need to change either the model, either the structure of our agents. Later, I try another way. I do not manually insert the prompt in this window. I actually define the message to feed to the system. Yeah, I think this is another way to feed the message to the system. But somehow it actually only gets the okay, it asks my input if I remember correctly, but you can try. This is not a very big issue. You can either write your prompt here or you just manually input here. Okay. So at this stage, it starts a group chat again. Okay. Select speaker field. Okay. So At first, it gives some comments. Okay, so but here we have some improvements. I will now step aside and let team head handle the analysis with using historical data. It's not 100% correct because I do not want the team head to do anything with historical data. So you can see there are more complicated configuration with a more complex conversation. That will be needed. So to the next part, let's see the team head to chat manager. Okay, to provide the analysis, I will do a combination of the technical analysis. Okay, it's good. Both the data analyst and news analyst. Okay, it's going well, and it starts to okay fundamental analysis. Okay, it tells you uh, part of the information, and also some subjective conclusion here. But the problem is that the two analysts have not said anything. Yeah, so this is I don't know how to define it, a hallucination or what. Uh, Here you can see the team head to the chat manager. Okay, disclaimer, blah blah blah. This is kind of a standard term again. So representation. Okay, subject to what? Okay, the group chat select speaker field again. Okay, so if it failed, actually the talking, I think is like the LLM one side output. It does not say who is speaking. So I will leave this kind of issue in the future to resolve. And at this moment, yeah, this is actually the one of the result of the server log. It shows a very messy picture. So just to wrap up, we have some issue remain. For example, this error code and the insufficient assignments of the job to different agents. And in the end, I think we can improve in the future. Like I said, the prompt, the agent's job description. I see it like this, and also uh, the detailed configuration of the usage of AutoGen. I think we will find also tons of example on the website. The problem is that most of the example on the AutoGen documentation is based on a OpenAI API or other uh, structure which you have to link to the API of the online LLM model. But if you are going to do with a local LLM Studio, you always need to do some tests to change the code to adapt to the local large language model. Yeah, I wish you find this tutorial useful and happy coding. If you have any question, feel free to leave a comment and I'll reply and also to have a discussion with you. So let's advance in the AI agents creation. Have a nice day. Bye bye. Hello everyone, welcome to my channel again. I'm going to show you another project that I have already done and see some very useful results. First of all, I would like to introduce this tool to you. It's called a Streamlit. Basically, it is a set of open source Python framework for data scientists and AI ML engineers to deliver dynamic data apps with only a few lines of code. So I find it very interesting because the deployment of this open source Python framework is just by pip install the package, and you can actually dynamically show the data in a web page. Uh, by the way, if you are already familiar with the different packages in Python, you know that you have millions of ways to plot the data. But this one is interesting because it can uh, deploy also in their website. I think in the app gallery, you can see here, there are lots of projects by different people, uh, and you can try each of them. For example, this one is showing you different type of chart. Okay, some example, you can see the code below and you can see the graph above. So basically, there are so many possibilities you can realize with this toolkit. For example, this one pretty map, I find it's very interesting because you just input the name of a city and you are going to get a very cute map. For example, you see this one. Yeah, I think it's Macau. Yeah, you can see the map in a very interesting form. So without further ado, I'm going to go to my project. So my project is to show the stock price dynamically. So the idea is that whenever I choose a different uh, store, the stock label, for example, AMD, right? I'm going to see the candle chart and also the 30, 60, 90 days moving average of the end of day price, just to visualize the stock price. Okay, this is a quite simple task. I mean, you can do it in many different ways using Python package. But here I just want to make something like a dashboard. The dashboard, I make the upper part. One upper left is about an individual stock. Then SP 500, the entire uh, SP 500 performance. And then on the lower side, I'm using some sample macro economic information. For example, this one is US GDP and the interest rate. Of course, you can also change this to your US GDP growth rate to interest rate if you think that makes more sense. Or on the lower right side, you can see the US inflation and the unemployment rate chart. Okay, so basically, I want to have this kind of a dashboard to understand the current situation. But based on this, you can add millions of other possibilities to add macro, micro, and even I think in the future maybe we can also explore the possibility to dynamically show financial performance of individual stock. So you can have a comprehensive view of the stock, general stock market, and the macroeconomic situation. Okay, so how do I get here? Basically, I need to have one, two, three, four Python file. This is the first time I try to build a few Python files and make them work together. Okay, so important thing is that you make them in the same folder, and eventually, if you want to run this app you build, you need to streamlit run main.py in your folder. Okay, so I will not spend time to explain to you about how to run it because in the documentation, in the example, there are a lot of description. It's very clear. And if you want to type some prompts to our system, usually you go to the terminal. This part. So basically, let me go through all these documents quickly. First of all, I have the let me show you the different sub pi documents. Okay, the first one is a thread. Okay, for security reason, I have already deleted the API key. You need to get the API key in Thread website. It's very useful. You can get different macroeconomic metrics, the different data sets, okay, like GDP and the federal funds rates and so on. It's very useful. Okay, if you interact with ChatGPT, you can get the code very quickly. And you see, first of all, you need to be able to import this thread API and also to fetch the dataset. And also you need the um, Streamlit at this moment. I think the most important part is about this part. To get this to work with the whole application. This is my assumption because I'm not an expert of coding, so I suppose this part serves to link to the app. Then we see the next part is about stock.py. Okay, previously actually the code was more complicated, but I got a lot of error. For example, I wanted to project the stock price for the next 30 days and plot them all together. However, during the process, because there are many definitions, many definition of the functions and the algorithm, it makes the file very cumbersome and complicated. So eventually, I get this rather simple format, I think, because you can see here. Uh, Let me try this one. Empty stock. Let me check. Yeah, you see, it only goes to the available information. Okay, 2024 March uh, of the data source. So it does not add the prediction data here. Okay. But I mean, you can do a lot of work to modify, manipulate the data set, but the main idea is here. First of all, to use the Y finance, this package, to actually to get the data from different ticker of the stock. Okay, add moving average. Of course, this is to have the moving average line. You can see here. Okay, and you can also cancel some of the data and you see the moving average. Yeah, in this way is more clear. And of course, I make the prediction price, this function. I believe this function works to predict, but eventually I failed to put them together, to put in the graph together. Okay, so this is the stock.py. Eventually, let's go to plot. The next one, we go to the plotting.py. In this part, I was trying to actually define different plotting function to eventually be used in the main file. Okay, so in this part, I think you can see basically we have two plot function. One is to plot economic data, the other is to plot the candlestick with moving average. Okay, so the most important part is that I'm using the Plotly, this package. I think it's very useful. Like you see, the display of the data is very dynamic. You can zoom in, zoom out, choose different uh, data to show or not show, and come back. Okay, yeah. So in this part, I think the most important part is to debug. Because if you use GPT or Copilot, you can get the code very quickly. But I always use GPT. I do not have Copilot, so I need to check with GPT each time with a part of the code and the error code to debug. Eventually, in the main file, it will import the necessary package, import different functions from the different Py file, and make them work together. So in order to get the Standard & Poor 500 symbols, it actually goes to the Wikipedia page to get the list. Then, of course, you can see here the sidebar here to select the stock symbol. Okay, it serves to give you this choice window. And um, the next part is actually to import the different functions of different Py file and make them work together, okay, so that you can check. I believe there will be some more ways to clean this code, make them more streamlined, more easy to read. But at this moment, I get this result. So eventually, this is the application that I get. You see it after I run this code, like I showed you before, stream it, run main.py. It actually jumps to this local server URL and you can see the result. I think it is okay at this moment because you see different data you can choose and it shows correctly. Yeah, and I would say this is a partial success. If you want to implement more complicated algorithm and to see more complicated results, of course you can try. And there are already some very good examples on the website you can try. I believe you will get more insight from there. And I wish my solution at this moment will be a start point for you to refer to. Okay. So if you have any question or any doubt, feel free to leave a comment. So I'll see you next time. Wish this will be useful for you. Thank you. Hello everyone, welcome back to my channel. I wish you had a great summer. Now, I would like to take this opportunity to share with you the agentic tool that I have been using lately. It's called Agent GPT. You can see the website in the URL box of the Chrome browser I'm currently using. Um, I'm recommending this tool because it is very easy to use as agentic workflow. Okay, so basically, I think two features of this tool are really attracting me. First one is it shows the tool calling process. The other one is that it is built under the agentic structure. Uh, Unfortunately, I have not yet seen the source code or examined in detail of the functionality of the website. But so far, I have get some useful results. For example, now if I want to do some web search, I would like to use it to like a starting point, to understand some of the search results. So basically, it's very easy. You just use your Google account or you create an account, and you just log in. For the free tier user and also the paid user, you have different plan. Okay, so I'm just going to show you two examples, just like it is like a comparison of the two scenarios. The first one on the left hand side, I would like to get 10 latest AI news in Italy. On the right hand side, I'm going to get 10 latest AI news in general. Okay, so you just input here the name and the goal. Okay, those fields are mandatory. You just insert and click run, it will start running. Okay, so you can see the first one is actually add a different task. This is very nice. Okay, it is based on your prompt. It creates a different task. So for each task, it will call different tools and to just to get a job. Okay, so you can see on the right hand side, it actually also called the tool to do the code. Okay, to get to write the code. So you can see some code is written. Um, in my experience, if you ask it, for example, now the free tier, you only have the GPT 3.5 version. Okay, so if you wanted to display the graph to output some of the data analytics information, it's not like a GPT 4.0 or GPT 4 where you can see there is a more robust tool calling and output of the results. But here you can get most of the text results and also some coding. You can also ask it to do some coding. Okay, so let's see. Now it already finished. Okay, finished all the tool calling and the research, and you see there is a max loop threshold, and you click summarize. You are going to get the final result. Okay, so it will give you, yeah, cite the source. This one I like it very much, and also provide the information as you asked. Okay, so just a quick review from the beginning. Okay, let's just review it again. So basically, the first does on the left hand side, you can see there is a stage where it added a lot of tasks. Okay, so it will execute each task. For example, the first one is search the web for AI news in Italy, right? It actually executed it. Okay, get, it's not 10, right? It actually gets 7. So I guess there could be some improvements. And you see the sources of the web search is quite wide. Okay, it's not only from like some renowned news resource or very well-known news resource. Okay, uh, and you see it continues with different tasks. Okay, and you can see this one: visit the top news website in Italy and look for AI-related sections. This is kind of like a more detailed task. Okay, so you ask for the AI news in Italy, so it will go to the top news website to look for the AI-related section. Okay, this is I would like to say is improvement of your prompt and actually embed this prompt into a more detailed task so it can run. Okay, then we can see here, read the latest news articles on Italy. Uh, I see a little bit repetition here because like the different tasks are aiming at the same thing, just in different way of saying it. Okay. The good thing is that for the web search, each site will also give you some of the source, the news of the source of news. Sorry, and later we are going to summarize, and you see in the summarize stage, it will get all the information that gathered above. However, we can see that it only summarized five news, and each news you have one, two, three, four, five. Everything is get from the web search result. Of course, because I'm using English, so most of the websites are still based in English. Most of them, like this one, Agenzia Nova. You can see it has a name, Italian name of the website. Okay, so it can also search some of the information in the Italian website, but mainly it is bounded by the language used, in English. And you see, it also gave some of the suggestion to explore latest news. You can visit the following website. Okay, so it actually gives you some additional tips that you want if you want to explore the topic. Okay, you can click the website to check. So far so good. Okay, on the right hand side, you can see the result is slightly different. Okay, you can see they actually have the different tasks like open a web browser, search for the news, filter results, show most recent. It looks fine and much better than left one. Compile a list of the 10 latest AI news article. Yeah, all looks good, right? So it actually first one is to let you know where you can find the news. Okay, then you start to search for the latest news and find some articles and always cited, right? You can see it's very good that it actually inquired the MIT website. So maybe this web search destination is very relevant to the task assigned. And you see here is the filtering of the article. Okay, example code. Okay, I'm not sure if this is what I really want because I wanted to actually filter the information already gathered, right? So it's like a quick filter of the data frame. However, it offers the a code. I'm not saying that the code is not useful. If you want to run it in your environment, you can try. Okay. So it actually finished here. Okay, so this is just example code. You can see that this is not actually linked to the result already shown. Okay, so I believe this one is useless to actually get the to filter the existing result. But the filtering step actually happened because in the next to calling, actually it compiled the 10 news. Okay, so I guess it already had some running and the ranking of the page in the backend. Eventually, you see here, you get news. It looks much more abundant than the left one because the range I did not limit to the location like Italy. And in Italy, there is also a language barrier. Okay, most of the large language model are focused on training English contents. Okay, so the Italian contents are not so easy to interact with the large language model. Okay, so more or less the same. As I said, it actually does different tasks and summarize. Okay, yeah. The summarization, of course, you need to initiate by yourself. Let's see the summarization part. First of all, you can tell latest news. Um, it actually shrink down the size of the news, the number of the news. I asked for 10. It gave me the summary only 5, and also additional suggestion on where to find the relevant information, and also Python code if we want to use it on our hand to filter some of the information. I mean, if I already get a data frame, it will be much easier, right? And I can rewrite the code. But if you just show here, I think it's just an indication that I could try it, but that's not a function for anything here. So then it actually gave me the compilation of the 10 news, okay? So in my opinion, some of the results have some repetition, right? Because like here, um, you don't need to, because my question is not to ask you to provide me with the source so I can check the source. I want you to check the source and give me the result. Okay, so I think there's some redundancy here of the reply. But luckily, in the end, I can see there are different information in the end. Let's try to click one of them. Click a link. Okay, there is the actual page. Yeah, but yeah, because I'm not subscribed, so maybe some of the content I cannot check. Feel free to check to verify if some of these links are real and if the contents are really cited. Okay. So I mean, using this tool can give you a quick start, but eventually, I think we need to, if we use a better model, for example, if you build a model by yourself, you call the GPT-4 or more advanced models, you can get better results in your local environment. If you rely on this tool, like the online version of the agent GPT, if you pay, of course, you get more of the advanced model. You have less restriction on the maximum loop and so on, and maybe you get better results. Okay, but in my opinion, this is a good tool for you to try. And also, if you want to uh, get from this model, I think one is its design. Okay, this is a tool calling and agentic workflow. But here, notice one thing: you don't see one agent talking to another. Okay, but it's called agent GPT. I assume that it is agent that get the different assigned task, detailed task, and solve it, provide the results. Eventually, you have another agent to summarize all the information. Okay, this is just my assumption. Feel free to try it out and let me know how you think about it. Okay. So wish you like this video and wish this tool will be helpful for you for web search, and see you next time. Bye bye. Hello everyone, welcome to my channel again. Today I'm going to share with you one of the projects I have done in recent days. Basically, this project was designed to interact with ChatGPT, another large language model, to uh, build a project with, first of all, a local database, simplified as several CSV file and PDF to contain the information that uh, is useful in my domain. And then I'm going to build um, query a query workflow with LLM Studio and also the LangChain. However, after interacting with the GPT, it does not understand the structure of LangChain. It actually diverts me to another sort of workflow to make my query work. So although you see the names of different Python file is called line chain, I leave it as this just to remind me that this is not line chain, but it can be a good start point to understand how to make your query to the large language model better or more efficient. In the future video, I'm going to focus on the LangChain documentation and to really utilize the LangChain workflow to improve our large language model query and get better results. Okay, or as the famous method, RAG, just to better utilize large language model. So first of all, let's go through this file. Just want to share with you on the left hand side, I have two TXT files. I make a record. The first one is about the key points. I actually made a lot of notes, okay, about the different tests, how I improve each file. If you find it useful, you can check it or pause the video and check it. Yeah. Um, and here, I'm going to focus on the step. The step part, I actually ask a large language model to better interpret my final result of the of the Python file. So basically, the project starts with first part one. Actually, I created two Python file to get the fine history, which were the history where the GDPR, in the EU region, how the GDPR law was enforced to fine the different corporates. Okay, so uh, there are two information sources. First one, I can go to Google News. Okay, this is a package. I like it very much. Can get the dataset very efficiently. The other one is Wikipedia. In Wikipedia, you can always find some summary, and it is quite useful, more structured data. And the last thing is about the GDPR law. GDPR law PDF is pure text, just the the wording of the law. And by running these two Python file, we are going to get um, these two CSV file. One is called the GDPR Fines Wiki, and the other is called the GDPR Fines. This one is from the Google News. Um, you can modify the code as you want, because now I limit the search result just to make it more efficient. Otherwise, for example, if I want to query like 1,000 entries, it will take a lot of time. But for the Wikipedia page, it's faster. Usually here I have two CSV files with the data that I want to feed into or interact with the large language model. I think is more updated and more focused on the use case that I want to implement. Then about the GDPR law, I actually downloaded the law PDF file and save it here. Right, if you you can check it on Google and download it from the GDPR website. It's very easy. So then I go to part two. The original idea, like I said, I wanted to use LangChain to interact with large language model, but I take the shortcut to use the LangChain documentation, and my idea, I feed it into large language model. It cannot understand how to use LangChain. So I suppose that either the LangChain methodology is too nuanced to the large language model, uh, or the large language model just cannot logically decipher the new methodology in the coding. Okay, like LangChain, the different mechanism to interact with large language model. But I followed it and step by step get the results. Um, you can also check the test versions in the past. I'm going to show you one of the example here. Here. So basically in this page, you can see on the left hand side is the standard LLM Studio query and response. It's very simple. Just give the prompt to the local large language model and get a response. On the right hand side, it was a mistake here about the HTML file, but actually the prompt to the system was part of the law, which is more relevant to the to my query, and feed both the relevant law part and my query to the large language model to get a more comprehensive response. Okay, you can see the difference. But I can tell you during different test, different trial of my code, I fixed a lot of bugs. For example, sometimes if you do not use the efficient query method to link your query to part of the text message, um, some of the query, some of the matching mechanism will just fetch the first paragraph of the law. It's not going to get the most relevant part. Um, if you are interested, you can check my past record, okay, in the test versions. Otherwise, you can go directly to the final version of launching LLM Studio version 5 or version 4. So let's focus on this final version here. Okay, we have the dataset ready, and we have also the PDF of the law ready. So now we're going to go through the project. Um, First of all, importing the different packages just to make sure that your code will run. The first part is to download the PUNKT. It is a data package for tokenization, for sentence splitting. Then my code actually define a simple vector, this class of simple vector. It defines how to store the document embeddings and the text documents. Okay, and especially about this part, about the search, this function of search. One time when I tried the code, I actually ignored some of the variables. So even if the system, even if the code can run, sometimes if you miss feeding some of the variables to a different function, you can get a result. But it is not a complete circle, complete workflow. So I really recommend you to check that every variable is utilized and to make sure that um, they are they are working in the workflow correctly. So in the next part, um, we are going to load the pre-trained, it's called pre-trained universal sentence encoder model, okay, from TensorFlow. Okay, it is also part of the very important part of the code. Then this code defined different functions. For example, you can check it one by one. The embed text function converts list of text chunks into embeddings using this universal sentence encoder. Okay, so basically, yeah, this is I think one of the most important parts of the whole code. Then there's load CSV data. So this load actually all the CSV data to put it in one data frame. It is not a very, I think it's not, may not be the best option to put them all together. But I just want to feed as an integral part of the data. Okay. Then I also change the CSV to text because in the model, if you are feeding a data frame to get embedding, okay, it is not working. You need to transfer it to text. Then, okay, this is the load CSV data and also CSV to text. Uh, about the CSV to text, really pay attention to the encoding. If you get any error, you see some result are not good, you need to change it. And one thing I want to mention about like here, like load the CSV data, if some of the data type is not recognized by the system or by the code, you need to change it, okay, or to specify it. Then we'll go to the next part about load and extract text. So basically, at first I only have the PDF as text information. I did not have the, I had also the data frame, but eventually if I want to make sure all of them are processed, I should both process the PDF and also the text TXT file. Okay, this is just to make sure that all the files can be passed to this function and the text can be extracted. So this serves as extract the text from the file. The next one is NLTK sentence splitter. It actually splits the text into sentences using the NLTK. Okay, so then it will load and split the text, into sentences. Okay, so all these functions seems so complicated, but eventually I'm going to summarize the whole workflow later so you can have a better understanding of it. So basically, each function will quote another function to give a periodical result, a sectional result. So you need to really pay attention. Okay. So basically, let me just repeat here. Take a sentence splitter is going to return tokenized information, and the load and split text is to split the document text into chunks. Then here, I think here these two functions were only one function because at first I only passed the PDF information to set up the vector store. Okay, it's like a query database. But later, when I realized that the data frame is better to convert to text, then pass to the function to get another vector store, I chose to create two functions just to make sure that I understand I'm doing two conversions from text information to vector store. If you find it too complicated, you can of course change this part as long as it matches your user case and make your code better. For me, I just keep it like this. So basically, uh, the most important part is that for um, after converting the text information to vector store, okay, it will return this vector store as a result. Then there is the function to define a generate response function. Actually, this one is the interaction with local large language model. It follows the pattern of LLM Studio. First of all, I want to say the reason I set the input variables as two vector store is to just to make my workflow clear so I understand there are two vector stores utilized. So my query will match, first of all, the PDF of the law, the information, then it will match the data frame I provided, but not directly. They are going to check on the vector store. Okay, so this query embedding is going to, first of all, transfer my query to embedding, then find the similar documentation from the respective vector store to find the most similar information from the two vector stores, and eventually the prompt will combine these two and with my query. Okay, so this will be the formal prompt to the local large language model. Here I want to emphasize the interaction with LLM Studio is nice, is local, is safe. Okay, at least for now, I think it's safe. Um, but now I do not see a very comprehensive tutorial on the internet to let you know how to avoid different mistakes, different how to debug everything. So you need to try. One of the way is to actually focus on the completion, this client chat completion, and create a function. Okay, you need to check here. This is a documentation of the explanation. You can copy this part to your local file so you can check it quickly. This is a very comprehensive explanation. From here, I actually debugged several things. For example, I set the presence penalty and the frequency penalty to avoid that in the end For example, if I have a max token of 3,000, the system will generate some random code or repetitive code tokens after 500 tokens. So that is not what I want. That is very messy and not beautiful. So here, as you see in the document, I actually used both the frequency penalty and the presence penalty, these two penalties, as the max value of 2 to avoid the system generate the error code as repetitive nonsense characters. I think both penalties work similar. But just to avoid the error I saw, I just put both of them as maximum 2.0. Okay, so like the frequency penalty, it will penalize new tokens based on their existing frequency in the text so far, and the presence penalty will penalize new tokens based on whether they appear in the text so far. I think their functions are very similar. Of course, you can try different variations. At this moment, I put all of them at maximum value. Also, I checked some of the uh, Google. I searched in Google how to debug this issue of repetitive characters that makes no sense in the LM Studio when we query a large language model. Uh, some people say that we may change the temperature because your temperature is too low. It will limit the performance and for example, my use case, I would like my result very precise. I don't want to get more creative output because I am analyzing a lot of GDPR. I want to get the relevant output as a report that I care about. So uh, here, my use case actually defines that I should limit the hallucination and creativity of the model, so I cannot loosen this parameter. Just want to share with you this point. About maximum token, however you change it, the result does not change very much because like the Llama 3 8B instruct model I use, it will more or less stop at 500, 600 tokens every time. Okay, so the output window is quite limited. Um, I mean, we can explore how to expand the output range, but at this moment, after multiple trials, this is 600, 700 is the maximum token size I can get from the response. So in the end, if you want to try different maximum token threshold, you can try it. But as my experience, there is a limit. Okay, with interaction with LLM Studio and the local models. So the next function here um, is to save the record, okay, to HTML file. I really find this kind of function very useful, and the format you can define it very easily, and um, GPT can actually produce very high quality code to make sure that the HTML report you see is well organized. And you can see also here we can quote our queries, answers with line breaks, and so on. So eventually you are going to see the HTML file very well organized, so you can utilize it to view your result. In addition, I also save a HTML file of the save debug info. The reason I want to see this one is that I want to see the flow of the whole Python file, the whole program, um, because from there I can check, for example, if some steps has some problem. For example, if like the chunks of the text is empty or the vector store is empty, I can better debug. Of course, for professional debugging or the traditional way of debugging the softwares of the code, I think you can find many useful resources. But at this moment, I find this quite useful, so I use it to save the debug info. Okay, so you can see the different variable in each step. Like this one is about the text chunks. This one is about vector store. Later I'm going to show you. And in the end, here is the execution sequence. Um, so basically, you can see we first of all we load the CSV file, then we convert CSV to text, then we split the documentation to chunks, okay, and we actually have two operations. First of all, is text chunks, is raw PDF document to text chunks. The other is the dataset, TXT version of the dataset split in chunks. Then we get the vector store one for the text documentation or the PDF. The vector store two will aims to store the vectors of the data text chunks. Okay. I know I repeat some of the wordings here. Maybe I can make this function and the display more neat. You are free to modify it. I just make such a separation to make sure that I understand the flow better. In the end, there is a user inquiry. The user inquiry you can always modify. I'm saying I am an IT company and want to mitigate a GDPR risk. What should I do? What are the penalties for non-compliance with GDPR? Use plain non-legal tone. Do you have some examples? I also ask. Provide a comprehensive report. Okay, so this is my user query. And when we want to generate the final answer, we actually use the generator response function to put our user query uh, with a vector store 1, vector store 2. So as you see the function above, it will interact inside, get a more comprehensive prompt to feed to the local LLM, large language model. And there we're going to print the final answer and also save the different information to the report HTML and the debug HTML. Okay, so that's it. The program finishes here, and let's come back to the left-hand side. You can always check there are different. This is a summary, okay, and let's check again about the main execution. Okay, the main execution is about the different steps. Okay, I really recommend you whenever you finish this workflow, just uh, ask a GPT or ask a large language model to organize the code, explain the code, get a summary of the sequence. So this one is not actually generated by GPT-4. It was generated by Hugging Chat using Llama 3 model. I think it's a Llama 3 8B. Uh, so I can have a better idea because after all these complicated functions, workflows, in the end, sometimes you forget. Okay. And the general workflow here is a more summarized, more high-level workflow. Okay, so basically, I think just to um, put it in a nutshell, we load data, we set up a vector store, we define user query, we generate a response based on the above resources and prompts, and we save the query and response to HTML and debug to HTML. Okay, and following up, you can see here I make some notes about version 4. Some of the major debug actions I did. First of all, I solved the tensor issue with converting data frame to TXT. Because like I said, when you feed the data frame to the vectorization process and so on, maybe you'll meet a problem. It's safer to transfer the data frame to text information. I did additional data cleaning. For example, like when the data frame actually had the non-available value, in some functions, sometimes it will generate error code and incorporate the text doc handling. So basically, it's related to the data frame to text and the text to text chunks and to vectorization. And the last one is change the data input as text input. Okay, so text chunk 1. So basically I did multiple debug actions to actually make it work, as you see. This kind of description is quite summarized and with a few words. If it's not clear, you can refer to the key point page. I'm going to scroll down again, and in the end. So if you have any question about any point, just feel free to ask me. My suggestion is that to keep your record registered, because in the next step you can come back and see how the journey goes. Okay, you build up this program to go through the whole workflow to generate better prompts and ask the local large language model. And in different version, you did something which could be very useful for your future projects. Okay, and let's come back. There is one last general comment that was generated by GPT-4. Let's read it. The code extracts and processes textual data from documents and structured data from CSV files. It uses embeddings to determine the relevance of stored documents to a user prompt. It then combines these relevant documents with the prompt to query a large language model, generating a comprehensive response. So let's go back to the beginning. I asked GPT to use LangChain framework to actually help me improve the performance of large language model. Okay, my objective was to generate a report, a GDPR risk is like a risk assessment report. Okay, suggestion report based on the dataset I gave, based on the law I gave, and ask a LLM to wrap them up altogether. Then regarding the database management, it also gave the comment like, okay, we are not interacting with SQL, non-SQL database. I mean, if you want to make it a higher level interaction, of course, you need to have such a database to actually make sure the large language model to interact with such, especially private data in your local environment. About vector store as a simple data repository, yes, it acts like a rudimentary in-memory storage system. This is quite important because it actually transfers the text information into this embeddings store, vector store, so you can query very efficiently. And about data loading and some of the techniques that we manage the data, of course, it also made some comments. Yeah, so remember, here it only mentioned about merging the data, and one more important point is that the data should be converted to text, at least for my example. I think it works in this way. Then uh, if the application requires more sophisticated data handling and persistent storage, okay, you need to have a proper database. Okay, is like the point number one, and you also need to have further considerations. Okay, this is just a quick go over of this project. Then let's quickly check some of the results. You can see this is the HTML file result. Left hand is debugging report. Right hand is GDPR compliance inquiry. And this report you can change the name as much as you want. So let's go through the debugging report first. So basically, we combine the data frame that we get. Is about the sanction historical data, how much fine was the GDPR authority actually sets to the different company, okay? But you see the format, okay? Like the second table, actually the format is different because we have different column title, so it actually moves to the right, okay? Then in the following part, we can see the first few sentences from the PDF, first few documents stored, okay, and the first four documents stored for the dataset. As you see, the dataset is also transformed to the text format. Then we can see the first few embeddings. Okay, it's all numerical vectorized data, and it's quite long. If you see, this is just the first few. I think first five, yeah, if I remember correctly. Yeah, this is also the first few embeddings. I think this part is about the data frame, and in the later part, we can see here is our query. Okay, as you see, the query was in the code, but this part I only showed the user query, but in the actual running of the program, the query is more complicated. Okay, it's not only about this part of the query, it's about the query including the embedding search of the existing knowledge base and also your query. Okay, so we can see in the end, we can see the generated response. I think it's quite comprehensive at this moment. Okay, you see that fines can be severe, and it actually quotes the both the clause of the law and also some of the information I think from its knowledge base. And what should you do? Okay, this one conduct a data protection impact assessment. This one because according to my work experience, I understand there is such assessment, so it's pretty accurate. And about um, a different suggestion, I think they all make sense. It's not 100% comprehensive, but I think it's a really good start point. And then it quoted some of the historical data of the fines. But here I doubt it actually used the data frame I gave, because I think the Llama model was trained actually before 2023, the data, or the beginning of 2024. So basically, most of the data I get are historical data, so which matches its training data. So here, I'm not 100% sure it actually queried my knowledge base, but of course we can check the log to make sure of it. Okay, if we are not sure about the query, how the query was constructed. Then about the comprehensive report. Okay, so it actually gives several sections. Then comprehensive report is here. Okay, we did do data mapping, privacy impact assessment, implement the security measures, training employee. Okay, it actually repeats a little bit from the previous section. Of course, we can further adjust our prompt or the penalty score to get a better result. Okay, really pay attention to the penalty score, because when I did not set it, I get a very long and very useless information. Additional tips, well, additional tips are also informative. Yeah, that's it. And you see here, we still have some of the not very good parts about the, I think it is like the repetitive nonsense characters. Um, for at this moment, I do not have a solution to it, but of course we can try to give some more clear prompt, structured prompt, even prompt template to actually confine our output in further step. So I think is okay. Then on the right hand side, you can see this is a much better structured compliance report. Okay, this is my query, and this is the response. Okay, the same as the left hand side. But on the right hand side, it looks like a very good and well structured report. Okay. Uh, One more thing I would like to share with you is that whenever you come back to the to see the test record I gave, you can check there are different versions of the debug report, GDPR compliance report. So basically, every step I improve some of the coding or improve some of the strategy. I actually build the different building blocks of the program. Uh, and when I realized some of the variables were not fitted into the different function, actually that was almost the last 2 or 3 versions. So basically, for the first four, I think first four versions, I did not actually include the vector store of the data frame. Yeah. So this is just a reminder to you that whenever you build this kind of program, really pay attention to see if all the functions are called properly, and to make sure that your answer is at least including all your current assumptions and resources. One more thing I want to share is that if you are asking large language model to give you, for example, like this search embedding part, okay, so at first it gave a naive strategy, okay, so I realized it only after I implement the 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 code several times. Then I realized it's called naive search in the beginning. So naive search is just to give you the top five chunks without actually running any similarity algorithm. So when I notice that, I ask again. So actually, GPT suggests me to do the suggestion, to do the similarity check. I think is a cosine similarity. Okay, just to compare your query with the the vector store. Okay, the document. So document embeddings. So in this way, it does not only show you the first top five of the according to sequence. Now it shows you the top five search results based on the cosine similarity calculation. Okay, so this is another point I want to share with you. The reason I want to share with you in the end because I think this one is actually going to determine if your prompt enhancing strategy is working or not. Because at first I only used the naive query, so the response change was not very obvious. There are also some other documents I want to share with you. For example, like when I did the two versions, okay, the pure LM Studio query on the left and the structured query on the right. At this moment, it was only combining my query with the naive search of the legal document. Every time I compare these two results, okay, I see which one makes more sense. It's like your local prompt arena. You can compare them. And even in the naive search phase, you can see that the right-hand side result is that does make more sense and can be more comprehensive. But you can run multiple tests. And of course, based on your different HTML, you can feed it to GPT or other large language model interface where you can upload the document, okay, to ask it for ranking. It is very interesting, actually. You see, GPT actually ranked the LM Studio response. This one is a very basic query result. Actually, give it a very high grade. But then you see the following 1, 2, 3, 4, all are the versions with the more reached prompt. Okay, where I have the query merged with part of the information that I provide, which I call it a local database. Okay, so you can also try this to grade the results. But again, however it grades the results, the user is you, the use case is based on your use case scenario. Always check to make sure that this output is matching your expectation. Here, as a final display, I would like to share with you the latest two running results of my code. So basically, this is the ML Studio server, first of all. Um, and on the left-hand side is the first time I run this code. On the right-hand side is the second time. So you can see here with um, all the functions, all the functionalities of my program, now I can actually enrich my prompt with a lot of data. First of all, um, about the data set I provided to the system, so it can actually refer to that data set. Okay, so you can see this is the content of the user. Okay, the system message is always the same. You are a professional GDPR advisor, specialized in GDPR compliance analysis, plan drafting, report generation. Okay, and here we can see the prompt like violation of different GDPR rules and different fines of different company. So I think the system is actually retrieving from the vector base this information. Okay, so the retrieval of this information, I would say, is successful. On the right hand side, there is not much change because I think the similarity of the vector store and my original user query remain the same because I use the cosine similarity. So basically, the engineered prompts are similar. They are all fed to the system to get a response. Okay. Uh, Previously, as I mentioned, I only included the law part. Okay, the legislative uh, PDF, and the system is fetching its vector space, vector store, and get the relevant information. However, after introducing also the dataset txt, we can see, of course, the information is more abundant, but we are not sure about the results. And very interesting is that now I think the system recognize less about uh, the PDF part. Okay, as you can see here, almost everything is about the past um, violations of different company. Okay, so I guess from a similarity point of view, the system now or our program is recognizing the similarity more on the data frame and not the law part. Now let's skip to the final compliance report. So both versions, I think, show a good template. I think for us to understand how do we mitigate the GDPR risk for an IT company. Although you see there are some small differences because each time you prompt to the LLM, it can generate different type of answer. Um, then let's go down. Um, about the end of the report, you see the problem shows again. So basically, before this version, I actually, uh, like I said, I tried to limit uh, the presence penalty and the frequency penalty. It worked, okay. But however, when you restart the program, sometimes it does not work again. So after these two attempts, I actually did one last try just a few minutes ago. And this version, I limit the token size to 1,000. Previously, it was 3,000. After limiting the token size, okay, the debug report is the same because our PDF text information, our data frame text information does not change. And let's see the final result is better, okay, but you still see here, okay, it was trying to generate some examples, okay, but it stopped because we have a limit of the token size. So in here you see there is no repetition, and of course the answer is structured in another way. You can see here. What should you do? Data protection by design, transparency and communication, data protection principles. Okay, it's like and I think this is more structured, like the legislative structure. Okay, but let's check this log because I just run it. I think we can open the log and see. So basically, whenever you open the log in LM Studio, you can see here. Okay, this is a prompt. Actually, after incorporating our database and the law. This goes to the system. You can see here, most of the information is about the past violation of the law, the records about the fine amount, and also the company name and so on. Still focusing on the data set. And because I have one of the CSV you saw, actually it get only 5 records. Okay, actually for that document, I think almost everything was cited. Okay, in this way, I suppose some of these characters, for example, this is a URL link. Okay, it's very complicated. It does not mean anything. But when we pass such type of information to the large language model, I do not think it will improve our results. Maybe create some confusion and so on. So anyway, in the last version, I think I just showed you the way to actually limit the error in the end of the answer by adjusting the token size. As I said, you can try multiple times. Okay, and also maybe also try the prompt template to actually get a better result. Okay, so just a wrap up of this project. First of all, I tried to ask GPT to incorporate the Lantern documentation with my project idea. It gave me alternative, so I have to refer to a different source, okay, to process the local information I have. Okay. Also, it was downloaded from the Genius package and also Wikipedia and also the GDPR website. Okay, it can be considered as external, but I save them as local, so I refer them as local. So I have this local data source that I incorporate with my query. Okay, so I get a final prompt. Okay, the chosen text message is based on the similarity to my user query, and I put them all together and prompt to the system and to get a final answer. So as far as I know, LangChain is utilized in more complicated scenario, but from what the GPT suggested me, I think from this project, I actually have some idea of building some simple project similar to this one. But the choosing of the embedding, vectorization, different method, I should be more careful and choose the best one for my use case. And I think there may be additional variations from this project I'm going to try in the future. For example, if I want to be an expert in interpreting the accounting regulations or accounting rules of a specific country like Spain, I might get all the official documentations, most of them PDFs, okay, and save it locally. And I can also get some accounting ledger example from the website, from different website, different open source information. Put them together to improve my prompt or to make it incorporate in the chain in the future. In my example, I only improved my prompt, but I do not yet incorporate the chain. But I think after this project, the basic idea I already get. Okay, I wish this could be useful for you. You may check all the example HTML, different Python program files. And if you have any suggestion and any doubt, feel free to let me know. So I wish it could be useful for you. This video is a little bit long, but I just try to go through every detail, every trial, every test as much as I can. So wish you good luck building your program and see you next time. Bye bye. Welcome to my channel again. Today I'm going to show you the pros and cons of using ChatGPT, which is my personal experience utilizing ChatGPT for coding, for data analysis, and also for the daily Q&A. On the pro side, first of all, it can be the inspiration and idea generation source. Can serve to do the brainstorming, help to structure and generate ideas. Then it now can interact with external resources, like it can link to the web search engine and to enhance the information retrieval. Then it now can provide more options of customization and also the query mechanism. First of all, it can let you customize GPT to limit the scope of the GPT to feed the different reference documents to make it more task specific. And by default, the fine-tuning process of the output can always include the prompt engineering. I think now is a very important topic that we can explore. About the cons, I really would suggest you to pay attention to. First of all, there is a usage limit. Of course, when you use the ChatGPT 4 model, at a certain point, it will tell you, okay, now you reach the limit. You need to uh, downgrade to 3.5 model and wait again for the limit to be restored. So this can be sometimes very inconvenient because when you uh, reach to a certain step of the project, of the Q&A sequence, suddenly you lose the capability of GPT-4, you need to use 3.5. It may deviate from your original designed trajectory of Q&A. There is also a hidden computational limits. I really would invite you to pay attention to this because as sometimes when you ask a very complicated question or you would expect more robust output, more comprehensive output, when you hit the computational limits, the answers will be very simple, very generic, and it seems like a protective mechanism of the GPT. So this is just my understanding. Uh, then, based on all these kind of limits, I think the recursive improvement challenge is also a result of different limits, like usage limits and also hidden computational limits. Because uh, eventually, when you repeatedly ask a question to improve a part of the HTML code, actually sometimes GPT does not improve at all because its knowledge is limited at some point. For example, when I want to modify a specific line of the code, I want to, for example, improve the aestheticity, the display of the HTML, it cannot do it. So in the future, if I have the chance to show you some demos, it will help you understand my point. But for now, really pay attention to this. Sometimes when you ask a question again and again, it may not get better answers. And furthermore, outdated information, it actually relies on the training data a lot. So if the training data is outdated, you cannot expect the large language model to get updated information, but you can improve the response from the GPT utilizing the updated data to fill in the data sets and so on to actually get better results. Okay, but still be careful about the information generated from the large language model, especially when you ask the question without feeding additional information. Uh, there is also additional personalized GPT limitations. For example, when you utilize a GPT, like one of the GPT I created, to ask the GPT to focus on the GDPR, General Data Protection Regulation in European Union, ask it to focus on that law and generate answers based on that law. I uploaded to my GPT. I created this GPT and also write a objective statement. Um, Sometimes it will refer to the document I uploaded. Sometimes it will ignore it and it give me the generic response directly. So I really recommend you to pay attention to this personalized GPT limitation because the answers are not always linked to your document. When you see that sign of query your uploaded documents, that is uh, the time when you have the results referencing the documents you uploaded, and at that moment, I think you can have a GPT that really uh, utilizing the material that you uploaded. Apart from that, really pay attention. Sometimes it only gets to its own training data and give you the prediction of the words as it likes. Finally, I would like to give you some recommendations. First of all, if you are not familiarized with different strategies of improving the output of the large language model, use multiple online offline models to improve the solution to a problem. For example, when I did some complicated coding, I would do the process like below. First of all, I ask ChatGPT, then I go to the Hugging Chat, and then I can also ask the Llama 2 uh, online version, and now we can even use Grok. Okay, so by interchanging to different models, you can improve the answer because their training data may be different, so you can get more insight. And sometimes, hopefully, you can fix complicated bugs. But that is really a rare case. Uh, Apart from this, you can try the RAG strategy. I think now it's very popular because like LangChain is designed for the RAG strategy. Uh, it will improve the prompt and also the information retrieval mechanism. I call it a query mechanism here, maybe not a very scientific term, but eventually the RAG mechanism is the main goal is to get a more robust response output. So in the next videos, I think I'm going to explore, especially on the RAG part, to share with you some of the journey I just made. But like the right hand side, this is the project I'm going to show you in the upcoming videos. Actually, I want the large language model to intake the document description of LangChain and also the local LM Studio code format to help me guide me through the creation of LangChain strategy, which is to implement a RAG strategy on local environment. So far, I can tell you, based on all these uh, cons, okay, the defects of the GPT and also the other language models, uh, all the models actually direct me to another solution. It's similar to the LangChain, but it guides me through uh, a journey to actually utilize the local data and the document I have and to improve my prompt and feed to the local large language model and get a response. So just to keep it quick, I show you this is basically the debug report. It actually shows you the steps of uh, the, the quasi LangChain workflow. Uh, it's not LangChain. It's how the large language model guide me to a workflow similar to LangChain. Basically, the code, the final code, first of all, utilize the data frame that I already have in place, and also the PDF. have in place and stored them into documents. Okay. Uh, Basically, the first saved documents is about the legislation. The second one is about the dataset. Okay, the dataset actually transformed to the TXT format for easy processing. And we got the embedding store. The embeddings are stored based on the information we provide. Okay, and we feed the query to a large language model. So here you see the query is only the query I designed to prompt to the system. The actual query to the system, to a large language model, is more complicated like this because it also retrieves from the uh, two embedding stored in the system uh, to get the most relevant information from the law and from the dataset I provide to the query, feed to the large language model, and get the below response. Uh, to be honest, when I get this response just 30 minutes ago, it is actually improved version from my previous results. So basically, next time when I share this project in detail with you, I'm going to share also different tests I had and some mistakes I made. But this eventual response I get is, um, I think I would grade it as 6 to 7 points out of 10 because first of all, it is not a very robust RAG mechanism I would expect. Second of all, this code structure and also the embeddings I created are not so robust. I'm going to share with you some of the defects of the project and also this result. You can feel free to replicate it and to try it. Okay, so basically today, just a quick wrap up. Whenever you use large language model for coding for different tasks, always pay attention to its downside. And now we have different models coming out like every week or even every day. Always pay attention to check it if it is suitable for your use case and try different strategy to improve the output to get your desired result. Just one last thing I want to remind you is that this HTML file you see on the left hand side is actually the result of this code here is called GPT summary. Here, actually, this summary is generated by ChatGPT. Uh, I mean, for this task, it's quite easy. I just ask ChatGPT to make my ideas, the information I want to share with you, into a nice out uh, nice displayed format in HTML. Actually, it did a good job. I think you can also try this. Okay, if you do not want to use PPT, if you want to use PPT or the Google Slides, is another story. Okay, so I wish you like the information I share with you, and I wish you enjoy utilizing large language model. And feel free to make any comment, discuss anything with me. If you like the video, give a thumb up and subscribe. Looking forward to share with you another project in the future. And thank you. Bye bye. Everyone, welcome to my channel again. Today I'm going to show you how to make a chat interface or user interface similar to ChatGPT in local environment. Basically, it requires you to download and install Llama and OpenWeb UI and Docker. So basically, with all these components, with Llama, you can host your large language model in local environment. Basically, you can directly interact with the large language model via the CMD interface, local command interface. However, if you want to go more advanced, you can link it with a user interface or interact with your Python code, Python environment. Okay, so Llama, the downloading and installing is very intuitive. This is the first step. Then you should install the Docker application. For me, I'm not an expert of Docker, but it seems like it runs the local server and provides you with a link where you can access the large language model. And the last thing is that you need to install the Open Web UI. The document is very clear. How you start with Docker. Basically, after you install the Docker, you should run the first installation instruction in your command interface. So just copy this one and go to your prompt. CMD interface is like this one. Where you can type CMD in the search button and you can go in here and just run run this line of code, and it should install an image in Docker and make sure you can run it. So basically, after all these steps in the Docker interface, you are going to see this one is an active container and with a port. Okay, you can open here and you are going to be diverted to the interface. Before you chat, you need to choose a model and you can start chatting. For me, I already downloaded the models from Llama interface, so I have several in place. The others I don't recommend you because after the testing, I don't think they are good. But the Llama 3, of course, I think is best so far. I've tested in local environments where its size and computational consumption are reasonable. So basically, how to use this Open Web UI? You can go to GitHub or their official website. This is Open Web UI documentation. You can find all types of suggestions. For example, like this one, tutorial. If you go to tutorial, you are going to find a lot of content. You can find the ones that you really want to use. For example, like the rag section, and for example, how you can um, chat with a website. Okay, so let's take a look at the real user case. So basically, I take the information or the idea from my previous project where I ask the large language model to generate the GDPR risk mitigation suggestion report. As you see here, I made some typo, but large language model can easily identify what I'm talking about. And as I said, um, I asked the large language model as a professional GDPR professional, generate a GDPR risk mitigation suggestion report to a new fintech company which plans to start business in Italy soon. Refer to, first of all, is the Wikipedia GDPR fines and notices web URL, and then the GDPR law URL, and also the additional legislative content. So let's open open these pages. As you can see, we have everything ready, and let's see how this model works. So basically, this report is well structured. I'm not going to the details with you, but from my understanding, because I also worked on the GDPR compliance framework design of a company. So I think the general content is useful and insightful. Of course, if you want to add more information, you can always do that. At this moment, I think is quite comprehensive, and especially it also cited the different sources that are utilized in the prompt. Okay, and you can see it also mentioned the Italian Data Protection Authority, Garante. This is an actual local authority to enforce GDPR and to enforce the Italian local data protection laws. So it's out of my expectation because it actually understands the specific country would require a different legal framework. So let's keep on looking the following content, like the conclusion. Yeah, it actually gives a very clear conclusion, and you see, because it's a suggestion report, it also had the ending showing some of the placeholder to show that this is a report from a GDPR consultant. It's well structured, and as you can see, uh, the result we get requires us to install different software, different packages in local environment, and we can run it. And this is a complete RAG workflow because we provided the context for the large language model to consume and provide such information. And because about the sanction data, I think it did not mention any actual cases, so I asked the model to add some cases. So basically, all these cases are real. I already compared with the data. You can also do the comparison. However, because I asked it to rank the top 5 sanctions from the Wikipedia website, it did not actually make a ranking. And you can see if we really rank the numbers, I mean, if we only look at the Euro ones, there is a WhatsApp sanction about 225 million. Let's see if we have that. No, it was not included. So there are still some limitations. So either we provide a cleaner ranked reference data for the rank process to reinforce our generated output, or we can do further prompt engineering. There are different ways to resolve this problem, I think. Then I ask a further question. Hypothesize 2 scenarios where company breaches which clause would be sanctioned with which amount or be taken which action, cite the law. It gave some hypothetical scenarios, and although the hypothetical sanction amount, the fine amount, may not be so realistic because it does not apply any model to predict that number, but the general simulation of the scenarios are good. And if you want to check against the law, I think at least from the article general title, it is correct. Okay, so if you keep on asking questions during this the chat, I think we are, first of all, we provide outside third-party source information. Then during this chat, it actually does second round of the RAG output generation, so we can have more comprehensive outputs. Then I ask it to consolidate the report. Of course, the general starting points remain the same, suggestions the same, and the top 5 sanctions listed, and the scenarios. The model kind of reduced the context, the token size of this part, but it is still acceptable if your expected report size is like this. And we have also a conclusion. Yeah, you see, conduct regular data mapping exercise, implement robust consent management procedure, develop comprehensive data protection policy, provide training to employees on GDPR requirements, and best practices for handling personal data. It's way above my expectation, because if you saw my previous video, I tried to do it with local rag, and either LLM Studio does not work as expected, or we have any other issues. For example, if our local reference data structure is not handled properly, and or our similarity check of the documents behave out of our control. So basically, at this moment, I think it works very well. And furthermore, I tested also the coding part. I have to tell you, I tried both to generate a PDF report based on this information, because I know this model cannot directly provide me with a PDF report to download. At this point, it's not as, for example, ChatGPT can already produce some. For example, if we upload a CSV file, ask ChatGPT to handle it, to modify it, it can provide a result. Or if we ask it to generate a HTML report, it can generate. But I don't expect the local one can do that, so I ask it to generate the Python code for me. Unfortunately, that does not work. Then I tried several times. All of these does not work. Okay, so I guess if we are asking it to provide the code to represent the chat history, it has limited capability. We can have a different alternative. For example, we can ask another model to uh, provide a simpler HTML format structure, so we can insert the information inside, or we can ask another model to provide a full code to embed the content in the HTML code or the PDF Python code. So you may try that, but at this moment, I understand its coding capability is limited, at least for this use case. So I would suggest you to also try out and explore more examples from the official documents, or you can go to different functionality in the local server interface. As you can see here, when you click the documents part, you can actually upload your documents or even import document mapping. As the introduction says, it provides you the capability of local rag um, ChatGPT capability. And also, as you can see in this prompt, you can also save your prompt, discover prompt, and you can see there are also model files. There are so many more that you can explore here. But as for my very simple user case now, I would stop here and leave you to explore the future use cases. So if you have any doubt, if you think anything is not explained clearly, feel free to leave a comment. If you like this video, give a thumb up, and I really wish you could utilize this amazing tool to start interact with it, or get insight, or get a task done in local environment. In my future videos, I'm going to keep on exploring how to better use large language model on different user cases. So until then, I wish you a good day, and please, if you like the video, don't forget to subscribe. Thank you, and have a nice day. Bye bye. Hello everyone, welcome to my channel again. Today I'm going to introduce you the tool to help you code faster and to assist you through all the procedure of coding. The name is called CodeGPT. It can be searched from the extension store in VS Code. The one thing I want to mention to you first is that you need to pay attention. There may be some other extensions which share the similar names. I think when you focus on the download amount, like this official extension has over 1.2 million downloads already. So I recommend you to check carefully. And of course, if you want to explore other similar tools, you can do it. But if you want to, first of all, find the most popular one, you can choose it with careful examination. Just do not, for example, like this one. Um, it has the same logo, but it does not mean the same thing. So let's come back. First thing you need to install it, and it will be ready. Having it installed, on the left hand side you can choose it, uh, code GPT chat, and this is the interface. You have many different options. For example, if you choose the provider, you can choose LLM Studio or Grok. These two are the interface or the large language model source I prefer now, because LLM Studio I can interact with my local models. Grok, I can interact with the Grok interface to leverage the LPU calculation. It is very fast. But if you want to use Grok, you need to get the API key. Get the Grok API keys. It's very intuitive. You just go to their website. If you have not registered yet, just register and go to the API keys section and create one. So uh, copy it, and you will going to use it in the VS Code environment by linking to the GPT code. We are back because I already have both the Grok and also the LM Studio both set up. So I'm going to show you how they work in practice. Let's just test with a very simple code generation and see if it goes well. Interact with LM Studio in local environment. The first thing is to open LM Studio and choose a model that you prefer. For example, for me, now I choose a Meta Llama 3 instruct. And after a while, it will load the model. Yeah. And after starting the server, it is ready to go. Back to the VS Code environment. Let's see here. We choose LM Studio, and let's try. Okay, write a Python snake game. Okay, so it just starts writing the code. The speed is quite okay because it is a small size model in my local environment. And I just um, created this Python file. Uh, and you see, when you go back to the top, there is an option. You can either copy and paste the code here, or you can directly insert the code. Let's try insert. Okay, the code goes to the right hand side. So let's try it. After installing the Pygame package and run the code, I see this pop-out window. Let's try if it works. Yeah, it works very well, and the speed is okay. You know, some time ago I tried with ChatGPT, and sometimes the result of this Pygame either has very fast speed or the interface is not very well. You know, it's not like this. So I think we have a success with LM Studio. Let's see. Okay. It cannot just go past the right border and emerge again from the left. Yeah, so let's stop here and let's try Grok. Let's choose the other option. It's called providers. Let's go to Grok. Okay, you can of course choose a model that it now supports. For example, now I choose a Llama 370B. Okay, because I already have my API set up, so it should work. Okay, I just copy the same prompt. Let's try. It's super fast. This is one of the advantage of it. Okay, just to save time, I'm going to directly insert the code to replace the old code. Now let's try again to see if it works. Okay, it is working. Let's see. Okay, let's get it. Yeah, it's okay. Some special case like what I just did. Uh, it still has some problem like when you hit a wall, it does not show a prompt. Yeah, you just restart the game. So in general, both code work. Yeah, and furthermore, if you want to understand the code on the right hand side, or you want to change something, the most um, direct way is to select the code you want. You want to change, you want to do any action, right click, and then you are going to see Code GPT explain, refactor document, find the problems, unit test. Okay, there are so many options. For example, let's try the explain Code GPT. Okay, so the code just go to the left hand side and you can see the explanation just goes on and on. Okay, so it is very convenient. Let's see if we can do the unit test. Okay, so yeah, it's working and it shows unit test for state gain initialization, test case 1, test case 2, and so on. Okay, so uh, I rarely do this unit test, but I think it just provides you more flexibility to test the different part of the code. Okay, so just feel free to try any of the function and wish you find this useful. Just remember you have it on the left hand side and it can interact with your code interface on the right hand side and pay attention if you want to use like the interface like Grok or OpenAI. You need to have the API key, and of course you can also choose Llama or LLM Studio. There are so many other options. Yeah, just find the one that suits you best. Uh, my personal suggestion is to uh, have a paid service like the paid GPT, uh, GPT API, and a free local version like Llama or Studio, because it just provides you with more flexibility. And when sometimes like I met some of the problem before, if you meet a repetitive situation where the large language model cannot help you with the coding, uh, changing different models sometimes may help. Yeah, this is just my suggestion. I wish you find this video useful. If you have any doubt, any question, any issue, anything you want to ask, you want me to explore in the future, feel free to let me know. So until next time, have a nice day and happy coding. Bye bye. Back to my channel again. Today I'm going to show you one of the example of data analysis which I did some time ago about analyzing the Melbourne housing market data set. This data set is available in Kaggle. I chose this data set because it was available, directly available, and it is very useful for us either in academic research, data analysis training, or in applying to a real world scenario where you want to determine if the housing price is overpriced or underpriced. So I think this dataset is very interesting. So in this video, I'm going to show you the comparison between the GPT-4o and my own project analysis. So on the left-hand side, I ask the ChatGPT to process this dataset, and on the right-hand side, I'm going to show you what I did. So basically, let's first look at the ChatGPT. First of all, I ask it to analyze this dataset by providing this URL. It cannot directly solve this URL, so it asked me to upload this CSV. Okay, so I uploaded this CSV. It started by showing the head of the dataset and so on. Okay, it starts to process the data, and I did not define the exact models that I wanted to uh, examine to run. So it actually thinking. It started thinking about which model is the best model to start the supervised learning process. Uh, Eventually, after checking the data set and so on, it started to suggest the three models: linear regression, decision tree, and random forest. If you are not familiarized with all these models, I suggest you to check the information of each model to make sure that you understand how it works. Okay, these are the very popular supervised learning models. So let's see how it does. I really like that uh, the GPT tries to put all the models in a bundle, and it uses a for loop to actually try the different models. It's quite